Today we're going to talk about graphing logarithmic functions. So our function f of x is equal to log base 3 of x. So we would read that as log base 3 of x. And a logarithm, the way we think about a logarithm is if it's a base 3 logarithm, we're thinking about 3 to what power would be x. So for example, I'm going to graph this. If I tried to make x 0, 3 to what power is 0? Well, there's nothing that's going to make that true. So let's try something else. Let's say that x is 1. 3 to what power is 1? Well, 3 to the 0 power is 1. Okay. How about 2? 3 to what power is 2? Nothing easy, that's for sure. How about 3? 3 to what power is 3? Oh, 3 to the first power is 3. 3 to what power is 4? Not good. 3 to what power is 5? Not good. 3 to what power is 6? Not good. 3 to what power is 7? No. 8? No. 9? 3 to the second power is 9. And going forward, the next number that's actually going to be good for me would be 27, because 3 to the third power is 27, but I don't have enough space to show that. Okay, how about negative numbers? Like 3 to what power is negative 1? Nothing. 3 to what power is negative 2? Nothing, because powers of 3 are all going to be positive numbers. So there is no power of 3 that's going to give me negative 2. Okay, so the only thing left to try are fractions. So 3 to what power is 1/3? Negative 1. 3 to what power is 1/9? Negative 2. So we get a look like this, with a slow rise over here, and headed for a vertical asymptote over here. You may be saying, wait a minute, I've seen that look before. We did. This is sort of reminds us of the graphs we were doing the other day. And what we have is sort of where our exponential growth graphs were rising and heading toward horizontal asymptote. These are growing more this way, more out, and heading for a vertical asymptote. So when we talk about these, we talk about the domain as 0 to infinity. Obviously, the range is negative infinity to infinity. The x-intercept, 1, 0. And we now have a vertical asymptote at x equals 0. Okay, so let's transform. Let's do f of x plus 2. That would be log base 3 of x plus 2. And what that's going to do is that's going to take all the points of our original graph and move them up 2. So we had a point at 1, 0, so that moves up 2. We had a point at 3, 1, so that moves up 2. We had a point at 9, 2. 1, 2, 4, 6, 8, 9, 2. So that moves up 2. We had a point at 1/3, negative 1. So that moves up 2. We had a point at 1/9, negative 2. So that moves up 2. So we've got this kind of look. still our vertical asymptote. Okay, so our domain is still 0 to infinity. Our x-intercept is now 1/9, 0. And our vertical asymptote is still at x equals 0. Let's try f of negative x, which would mean log base 3 of, oops, let's try that again. Log base 3 of negative x. We know when the transformation puts the negative on x itself, that is a reflection over the y-axis. So instead of my graph being all to the right, my graph is going to be all to the left. So my point at 1, 0 is at negative 1, 0. My point at 3, 1 is at negative 3, 1. My point at 9, 2 is at negative 9, 2. 2, 4, 6, 8, 9. My point at 1/3 negative 1 is at negative 1/3 negative 1. We also have negative 1/9, negative 2. So we've got this look. Oops. My vertical asymptote. My domain is now negative infinity to 0. My x-intercept is at negative 1, 0, and my vertical asymptote is at x equals 0. 2f of x would mean 2 log base 3 of x. That 2 is in the vertical stretch spot, so every point is stretched twice as far away from the x-axis as it originally is. So my point at 1, 0 is still at 1, 0, because twice 0 is still 0. My point at 3, 1, well, 1 doubled is 2, so now it's at 3, 2. My point at 3, 9, 9, 2, 2, 6, 8, 9, 2 is now at 9, 4. My point at 1/3 negative 1 is going to be at 1/3 negative 2. And 1/9 negative 2 is going to be at 1/9 negative 4. So we're getting kind of a stretchy feeling. General shape still the same. I didn't distort it significantly, but we do have some distortion. So my domain is still 0 to infinity. My x-intercept is still 1, 0. And my vertical asymptote is still x equals 0. Let's try a different base. Let's try a base 5 log. So five to what power is 1? 5 to the 0 power is 1. 5 to what power is 2? Nothing. 5 to what power is 3? Well, there is something, but it's just not pretty. 5 to what power is 4? No. 5 to what power is 5? Well, 5 to the first power is 5. The next good number is not going to be 10. It's going to be 25, because 5 to the second power is 25. 2, 4, 6, 8. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25, 2. Okay? Fraction-wise, I want 1/5, right? Because 5 to the negative first is 1/5. 1/25. 5 to the negative second is 1/25. So we get, it's sort of hard to draw because you have to go a long stretch before you get to rise it all. So my domain, 0 to infinity, my x-intercept, 1, 0, and my vertical asymptote, x equals 0. But if we compare this to log base 3, log base 3 it was rising a little faster than this one. This one is taking a long time because I'd have to go all the way to 125 on the x-axis before I could say log base 5 of 125 is 3. Okay, let's look at the natural base, e. So log base e of x, which actually has its own name. It's called the natural log of x because it refers to natural growth. Again, since e is about 2.718, log base e, or natural log, is going to look a lot like log base 3. I'm going to actually show it on our calculator. Here's my natural log key, so natural log of x. And I'm going to zoom 6 because I'm not sure what window I'm in. Zoom 6. Okay, so there's natural log. If I put it on the same grid, I can't put it on the same grid as log base 3. Never mind. My calculator is showing this sort of slow growth. It's doing its best to show it's got a vertical asymptote, but if you're not familiar with the general shape of logarithmic functions, you might assume that it stops right here. But if we look at the table, we can see that none of the negative values, if x is a negative number, I don't really get values, but I do start getting values at 1. 1 is 0, 2, 3, 4. And if I were to count my table in smaller increments like fractions, we start at 0 and count by tenths. Okay. I'm going to see that 0 doesn't have a value, but everything after 0 does have a logarithm. Again, let's go back to the graph. It looks like that. So its domain, 0 to infinity, x-intercept, 1, 0, and vertical asymptote, x equals 0. Okay, so watch this as many times as you need to.